so going over the fifth, the first one most people got right. The only issue most people had with the first one was Sig Figs, and there are 3 Sig Figs here. So you have to have 3 in your final answer, so 0.583 moles of iron 3 hydroxide gets you your 3 Sig Figs. Mole to mole are pretty easy. I don't think anybody missed that. The second one, you're going mass to moles. So you have one extra step of getting into moles before you can use your mole ratio. So you've got your grams of lithium hydroxide. You have to figure out the molar mass of lithium hydroxide. A few people missed that. That's not an indication that you're struggling with the concept. You made a dumb mistake. Easily fixed. And then your very last square is your mole ratio, because you want to end up in moles. And the thing that I realize, I don't know that I explicitly mentioned this. When I talk about the gospel of factor label, if you set the problem up, it will solve itself. The thing to do is check your units. So consistently straight through, as you go through the problem, you go, oh, units and chemical, I should say. Grams of lithium hydroxide, well, that cancels grams of lithium hydroxide. Okay, good. Moles of lithium hydroxide cancels moles of lithium hydroxide. That's good. I end up in moles of iron 3, and that's what I want. And then you know, oh, I have this set up appropriately. So you should always look for those things to cancel out. And I think for people who did have larger problems, doing that will fix your problem. So in the next one, you're going mass to mass. These are the big ones. So we start off with our given as always. We have our conversion to get into moles. And once we've done that, we can do the mole ratio from the equation. Once we do the mole ratio from the equation, we have to reconvert to get the thing we're interested in into grams. So again, if you check your units, grams of lithium nitrate, grams of lithium nitrate. So far so good. Moles of lithium nitrate, moles of lithium nitrate. So far so good. Moles of iron nitrate, moles of iron nitrate. And that leaves us in grams of iron 3 nitrate. So again, if you are having a problem with these, that little double check will save you a bunch of heartache. And it just allows you to, you immediately see if your setup's wrong. If all your units and all your chemicals do not cancel, your setup is incorrect. You need to check it. So the thing that I'm seeing a few people doing is trying to go from moles of one thing to grams of another, and you can't do that. You have to go from grams of substance A to moles of substance A to the ratio between A and B to grams of substance B. So let's go to the last two. Okay, in the next one we're going from moles to mass. Oh, there we go. And so we start off with our given. Again, check your units. Moles of potassium iodide, moles of potassium iodide. Moles of lead 2 iodide, moles of lead 2 iodide leaves us in grams of lead 2 iodide. And that was one where a lot of people, this was a mistake a lot of people made, was getting the wrong molar mass for lead 2 iodide and writing it as PBI rather than PBI2. That's easy to fix. With Sig Figs here, this was the other mistake I saw a lot of. People wanted to take this and to do 3 Sig Figs, make it 565 grams. So here's the question I always want to ask you. Whoops. If I owe you $5,650 and I say, well, I'm just going to pay you $565, is that the same amount? No. So you have to maintain all those placeholders. And if you're dropping something at the end, it just gets a 0 as a placeholder. Also, if you put a decimal and 2 additional zeros back there, you've just made more significant figures, because those zeros after the decimal are significant. So just review your rules on Sig Figs. Okay, last one, you're going from mass to mass, so it's a long setup. We go from grams of potassium iodide, grams of potassium iodide, moles of potassium iodide, moles of potassium iodide, moles of potassium 2 nitrate, moles of potassium 2 nitrate, and we end in grams of potassium 2 nitrate. So you get 359.2 grams. These are just sort of general helpful hints, and you'll notice if you look at my key, and I will, like I said, I will scan this in, On the side of my paper, anytime we're doing stoichiometry, what I tend to do is as I start getting the problems, as I start into the problems, I do all of my mass calculations down along the side. When we're doing the really huge, like limiting and excess reagent problems, where you're going back and forth between multiple reactants and products, and you're really using all the things that are in there, I typically just jot those right down the side first. And some of you seem to be just doing it on the calculator and not writing it down any place for yourself. And I will say I think you're more prone to error that way. And if you do make a mistake, you can't see where you made it. You know, did you reverse 2 numbers from the periodic table? Did you, it's impossible to tell. So leaving a paper trail for yourself is helpful. Questions, comments, concerns? Okay, I'm going to post it online. Tomorrow we'll pick up some of the limiting, or no, we won't pick up limiting and excess yet. We'll basically keep doing some stoichiometry. So, okay, that's it.